So here we're going to find the zeros of this polynomial. And my phone is pinging. I don't know why. I have no friends or any possible need for someone to get in touch with me for any reason whatsoever. I'm a troll. And I live under a bridge. So here's your polynomial. And we're going to use our same methods we've been using before, but in case this is the only video you're watching, we'll go into some level of detail. So I'm going to use synthetic division or long division. Remember the limitations of synthetic division, but I'm going to start out with synthetic division. And I could choose any x that I want because currently I have infinitely many x's to choose from. But I'd rather not have a 1 divided by infinity probability of getting the correct one. So I'm going to use Descartes' rule, rational zeros theorem or rational roots theorem. And I'm going to find the possible rational roots. I labeled this constant p and the lead coefficient, which is 1, q. And I find all the possible all the possible factors of p, which are plus or minus 1 and plus or minus 2. And all the possible factors of this number q, which is 1. So that's plus or minus 1. And then, as Descartes informed us, I find all the possible combinations of these factors divided by those two factors. And of course, since this is dividing by 1, I get the same factors in my list. So my possible real roots or zeros of this polynomial are plus or minus 1 or plus or minus 2. If it is not, if our zeros are not in this list, they are not real or rational. Sorry, the rational zeros theorem. They have to be real and rational. So there are two categories of numbers that are not real and not rational. That would be irrational numbers and complex numbers. So we're going to choose 1. And we're going to write our coefficients 1, -1, -4, -2. And we're going to do a little synthetic division. I'm going to bring down the 1. I'm going to multiply times 1. I'm adding, remember, it's different from long. And so I get 0. 1 times 0 is 0. I get -4. 1 times -4 is -4. And I get -6 when I add those two. So 1 did not work. 1 is not a 0. All right, so we're going to try -1 next. And so I'm going to write the coefficients down. I'm going to move a little more slowly. Bring down the 1. -1 times 1 is -1. I'm adding those numbers, so I get -2. -1 times -2 is 2. I'm going to add those numbers. I get -2. -1 times -2 is +2. When I add those numbers, I get 0. And boom, I get my 0. So now that I know that -1 is a 0, or a root, then I know that the factor is x plus 1. Because remember, I set it equal to 0 and then subtracted 1 from both sides. I know that that's my factor. I know that this is my quotient. That's going to be x squared minus 2x minus 2. And that equals the original polynomial, the original function. Okay? So they're equivalent. This one just has one factor factored out. Now, again, as I've said to my students, we want to get to the place where we get to this quadratic because we have better tools with which to factor quadratics. Even if we have to resort to the quadratic function, we have better tools than long division and synthetic division. So I'm going to try to factor this, and I'm going to notice that -2 only has 2 factors, or 2 pairs of factors, and neither of those 2 pairs of factors add up to -2. So I cannot factor this. So what am I going to do instead? I'm going to use the quadratic formula because it's unfactorable. So I'm going to leave this alone, and I'm going to deal with this part. I guess I didn't need to really write that. So remember, the quadratic formula is x equals -b plus or minus the quantity b squared, the square root of b squared minus 4ac. I said quantity instead of square root, and 2a. And I'm going to substitute my b value, which is -2. So remember, that's -2. I'm going to substitute in, I try to tell my students to put parentheses around everything. That'll hopefully minimize the number of times or the errors made with negative symbols. So I got plus or minus the square root of -2 squared. That one's not going to matter. Minus 4 times, let's just put those down. And this one there. Get all that squared up ahead of time. And then we get 4a is 1 and c is -2. Scoot this up. And I have 2, because this negative and that negative, plus or minus the square root of 4. -2 times -2 is 4. Minus -4 times 1 is -4. -4 times 2 is +8. Divided by 2. Oh, I forgot to substitute that in. This was a, which was a 1. Continue. 2 plus or minus the square root of 4 plus 8 is 12. And then I'm going to simplify this radical. And this is equivalent to 4 times 3. But isn't the square root of 4 just a complicated way to write the number 2? If I put an intermediate step to help those students that are not mine, I think of it that way. Split that up. And then this is just a complicated way to write the number 2. And remember, this 2 divides into both of these terms. And so I get 1 plus or minus 1 times the square root of 3. And so I get those two roots, 1 plus square root 3 and 1 minus square root 3. And we had this factor previously. So if I write those out as the polynomial and its factors, x plus 1, x plus 1 plus square root 3, I'm sorry, what did I write x plus 1 for? It's x. Oh, that's because it's that. It really should be there. And then x minus 1 minus square root 3. Right? And that equals my function. Because it's always x minus the factor, or the root or the 0. I can simplify that just a little bit and write x minus 1 minus square root 3 and x minus 1 plus square root 3. But it doesn't matter. You're going to type in the things in parentheses, these two, in here. And if I can find my mouse, then we'll be pretty good. So I get -1, comma, 1 plus SQRT SQ, come on now, SQRT 3, comma, 1 minus 3. And we should be good to go. All right, hopefully that helps.